Okay, let's talk about special right triangles, and we're going to look at how the lengths of the sides of a 45, 45, 90 triangle are determined, and we're going to look at how are the lengths of the sides of a 30, 60, 90 triangle determined. So first examples, find all the missing sides. In the first triangle ABC, we've got the notation that tells us that this is a 45, 45, 90 right triangle because of the notations here and here showing side length congruence. We've got an isosceles right triangle is 45, 45, 90. One leg is AB has a length of 10, therefore BC has a length of 10. We've got our two side lengths. And then we know that the hypotenuse in a 45, 45, 90 right triangle is root 2 times the leg. And so we've got that side length AC to be 10 root 2. Again, in triangle QRS, 45, 45, 90 right triangle, the hypotenuse has a length of 8. The legs, which are congruent, are going to have a length of the hypotenuse divided by root 2. Well, if we rationalize the denominator, we've got to multiply by root 2 over root 2. That ends up getting us 8 root 2 on the top divided by 2. Simplifying one more step, we have 4 root 2 for side QS and 4 root 2 for side RQ. Okay, here's another 45, 45, 90 right triangle. Find AC, which is the hypotenuse. As we saw in the last example, the hypotenuse is root 2 times the leg. That gives us answer choice D. How about finding a leg given the hypotenuse? Hypotenuse is 5. At first glance, it looks like the leg, which is the hypotenuse divided by root 2. Looks like D might be the answer, but you'll notice that it isn't rationalized. The denominator isn't. So we go one more step and look at 5 root 2 over 2, which is going to get us the correct answer here. Answer choice B. Okay, this hypotenuse has a radical in it, 8 root 3. We want to find the leg BC. So what's it look like when we take 8 root 3 and divide that by a radical, root 2? When we rationalize, remember your properties of radicals, we can multiply the 2 and the 3 and combine radicals there, all divided by 2. One more simplification, 4 root 6 is going to be the side length for this triangle. So that's answer choice D. Now let's shift our attention to 30, 60, 90 right triangles and fill in all the missing side lengths. Remember that the side opposite the 30-degree angle is the short leg, so that's 10. The hypotenuse is always double the short leg. So if the short leg is 10, the hypotenuse has to be 20. And the long side, the long leg, which is opposite the 60-degree angle here, has to be root 3 times the short leg. So in this case, 10 times root 3. So in this example, what's AB? The long leg when you know the short leg is 12. Again, it's the short leg times root 3. So answer choice D there. How about side AB? Again, the long leg when you know the hypotenuse. Well, the hypotenuse is double the short leg. The long leg is root 3 times the short leg. So we want root 3 over 2 times the hypotenuse, 5 root 5. Well, that's going to simplify by combining the radicals in the numerator to be 5 root 15 over 2. Answer choice B. Now we're looking for the hypotenuse when we know the long leg. The long leg is root 3 times the short leg. The hypotenuse is double the short leg, so this needs to be 2 times the long leg over root 3, which looks like 30 over root 3. We want to rationalize, and so we end up with 30 root 3 over 3. Last step to simplify, and we get 10 root 3. Answer choice D.